Hi, this is Muhammad again. Let's start the remaining part. The last part, what we finished is about, we can check over here, starting up calculation, weather properties, space properties. Today I am going to show the system properties. For the system properties, let's start the last part. From the last part, resume from the last part. On your screen you can see cabin 01. This space we have created in the last video, and for making full use of this example, I am going to duplicate this space, and I will stimulate the way that I have created many spaces over here, and I will duplicate it here. It's going to be duplicate over here, many spaces, duplicate, okay, duplicate, okay, duplicate, 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 duplicate. Okay, so there are around 1 2 3 4 5 6 7 8 9 10 11 spaces. So if you again see the same drawing, let us assume I have created all these spaces, 1 2 3, all these spaces. Let's assume this whole building include 11 spaces, and in real scenario it's not 11 spaces only, it's more than or less than 11 spaces, but I'm assuming that it is 11 spaces. So let's rename it, and yeah, I'll just rename as, the option will be here, just double click. So it is, let's say it was meeting room, and another one is cabin 2, maybe it might be cabin 2, and this is cabin 3, and cabin 4, cabin 6, cabin 5, cabin 7, cabin 8, cabin 10. In the real scenario, these cabin information is going to be differ cabin by cabin depending upon the orientation of the building, and the orientation of the building, orientation of the space, area of the space, length of the wall, height of the wall, and about exposed roof, or many information, lighting information, lighting fixture information, and number of fixtures what we are going to use. All this information, depending upon all this information, all these common factors going to be depend. For example, if you see this cabin 10, 100, 12, 71, same as cabin 1. We just duplicated all these cabins, all these rooms, but in the real scenario you have to take care exactly what exactly the area, what exactly the height, all this information in the real scenario, which when you are going to calculate the real calculation. By considering the example what we have seen in the last video, you have to create each and every space differently, separately, for all remaining rooms. But here let us assume I have created 10 spaces over here, around 10 to 11 spaces of by different names, meeting room, cabin. Let's say this is not cabin 3, but it is a conference room, because we may have a conference room in the office to make it is in a real practical example. Now I have to select a system for these spaces. What exactly mean till this part? Till this part we have just created the space information. Now the important part is we need to select a machine for these spaces. So before going to select the machine, the process of selection of the machine in the HAP terminology called system properties. The machine itself called system. Which type of system you like to prefer to this area? When you call the system, you have a chill water system, you will have a DX system. In the chill water system you will have air handling units, fan coil units, if you already aware of these air handling and fan coil units, and in the DX system we have split unit, package unit, window units. So to make this example real world, we will consider it as a regular system which is going to be used in huge projects like chill water system. If we are considering the chill water system, I'm going to consider an example of air handling system. What is exactly is mean? The mean that in this whole area, this whole spaces, I'm assuming, just remember, make note, by one air handling unit or two air handling unit. But to make example, perfect example, I will consider as two air handling units. Half of this space going to be covered by one air handling, another one is another air remaining rooms will be other air handling unit. Let's divide these spaces between two air handling unit. How these divisions going to be happen, and how, in what basis, in what scenario it is going to be a different topic. It will comes under a zoning and in a different parameter which is going to be discussed based on the request and based on the available time. But the real scope of this video is to how to use this HAP software by creating all these spaces and by creating the system. So as we agreed, we are going to consider two systems, which is air handling unit here. So let's consider AHU1 and AHU2. From half of the spaces I will dedicate it to AHU1 and the remaining spaces for AHU2. Let's start creating the system from here now. So system properties, click on the system, default system, double click. You will find 1, 2, 3, 4, 5 tabs, but only you need to enter the information regarding 3 tabs. One, this is general, system, components, and zone component. The remaining will be automatically generated by the software depending upon this information what we enter in these 3 components. So let's start from the general. As I said, we need to just enter the information asked by the software, which is here, which is asking one by one air system name. Let's say AHU1, which is air handling 1, AHU01. Equipment type, here you can find lot of equipment types. You need to select a proper suitable equipment type. Which is type of equipment it is? It is a package rooftop? No, it is not package rooftop. Package rooftop comes under DX units, and package vertical also comes under DX unit. As AHU is a chill water unit, you need to select chill water air handling unit. You can see over here, chill water air handling unit, and air system type, which type of system you want to prefer, CAV or VAV. What is CAV means? This is constant air volume. VAV is variable air volume. Depending upon the building requirement and specification, project requirement, and client demand, you have to select which type of system you want to select. To make it example simple and easy, select CAV, constant air volume. Again, what is exactly constant air volume? The professional or the viewer who don't know the difference between VAV and CAV, again it is going to be a different discussion and topic, which is I'm not going to discuss over here due to the limitation of the time. As of now, I'm considering it as only CAV, single zone. You can see in the CAV also various types: CAV, terminal reheat, 2-deck, 3-deck, dual deck. It is all about the type of the system you are going to be select, which is again going to be depend how much knowledge you have about the system or the units. But for the basic principally and basic example, I'm just considering CAV as a single zone. So number of zones 1, because I'm selecting as its single zone, that's why it frees to gray color as 1. If I select another one, it will consider as a number of zones. So let's consider only as a single zone. This is the general information, the way you have entered. The next is system components. In the system components, you must understand what exactly appearing over here. If you know the air handling unit over here, but first you need to understand what is air handling unit. The air handling unit, the HVAC design engineer must know what exactly the air handling unit. The air handling unit, if I show you exactly a small example, air handling unit, let's say AHU images. Yep. view image. If you see in the screen over here, you will see an example image of air handling unit. If I say air handling unit, it's consider a number of it may consist number of components. The major three components are it is very complex. Let's take a simple one. Yep. Yeah. View image. Okay, now you can see clearly this is air handling unit in the real scenario, the real picture of the air handling unit, which consists of one frame, box type frame, which consists number of components. Mainly it will have three sections: filter section, coil section, and fan section. In the filter section, this is the filter. The filter purpose of the filter will clean the air which is entering into this air handling unit. We have a coil system, which is the coil here, which is also called heat exchanger, but we generally used to call here it is a cooling coil. This is a cooling coil section, and this is the fan section. So what is the importance of the components over here in the HAP? So if you see the HAP in the system components, you can see over here the components over here: the ventilation air, economizer, ventilation reclaim, pre-cool, preheat, humidifier, dehumidification, central cooling, all this information. You must click on appropriate component which is going to be located in your future air handling unit for which you are going to design. For example, let's consider this is the air handling unit in your mind when you are going to enter this information with simple three basic components. It must have the filter, it must have the cooling coil, it must have the fan. So, and it must have ventilation air provision. Ventilation air provision means there will be a fresh air provision in the air handling unit. The people who know exactly what I mean, the air handling unit or any unit, whether it is air handling package or DX unit, you will have a supply air duct, which is after this fan there will be a duct, and return air duct exactly before this lower there will be a return air duct, and there will be another duct which is outside air, and that is also called fresh air, and that's also called ventilation air. So what is ventilation air over here? It means that you need ventilation air provision also in this system, but means in this machine which is air handling unit. So you need ventilation air, so I'm just clicking it OK. And economizer, generally you won't consider economizer, there won't be any economizer, there is no component called over here as economizer, so you don't need the economizer, you don't need the provision for ventilation reclaim. And the pre-cool means if the fresh air which is coming to this machine is already cooled, means some of the projects the fresh air coming out of this atmosphere, it is raw air, which is untreated air, which is uncooled air. In the most of the projects, this air most of the cases is treated and pre-cooled. So if you need a pre-cooled air, you have to consider this option over here. Now I'm not considering this option. Again, I'm considering this not pre-cooled in air. This is not going to be pre-cooled air. This is only raw outside air. So next option is humidification. There won't be any humidification. There won't be any dehumidification components over here. But there is a central cooling. So there will be a cooling coil. So you have to click on central cooling, and there won't be any heating. If there is any heating, you have to consider, but I'm not considering any heating coil over here, so remove this option. There will be a supply fan, of course. Here there is a supply fan, DIDW centrifugal fan, and there will be a duct system. Of course, if you are considering air handling unit, is going to be connected with the duct system by which the air going to spread out the whole area, whole office area, whatever the area it is going to be designed. So it also consists the duct system. So now this is the ventilation air, central cooling, this is cooling coil information, supply fan, and duct system. This is what it means system components. Now see one by one. Ventilation air, you are not going to change anything here. Central cooling, you have to make sure it should be 54 Fahrenheit, because the standard design for the central cooling, the supply temperature, which is over here it mentioned as supply temperature, it must be 50 to 54 again it is completely depends on type of building and type of load and type of area. For example, we are selecting this air handling unit, for example, for the industries or textile industries where you need more humid condition. For example, if you are selecting this air handling unit for the gym area, for where you need more latent heat, so this temperature going to be differ. This is completely a trial and error. So but in general case, for office and residential purpose, we will consider it as 54 to 56 or 52. So this is a 54 Fahrenheit what we have considered over here. The coil bypass, it will be the same, and this is cooling source. What is the cooling source over here? If you are considering a air handling unit, the chill water system, obviously there will be a chill water cooling system. That's why it's not considered any other option. By default is a chill water. Schedule type, this is JF, MAM, JJ, ASO, and ND is all about the month, January, February, March. So all information, remaining information will be freeze as it is. Come to the supply fan section. There is no need to enter any other information. And if you know the static pressure of the fan, you can enter, let's say 400 pascals. It is not in pascals, it is in inch of water gauge. So enter, maybe it's 4 inch or 2 inch, whatever it may be. If you know this static, if you don't know static, let it will be 0 as it is. So there is no information need to be changed over here. Duct system, duct heat regain, keep it as 10%, duct leakage 5% to be safe side. What it means, duct heat gain means there is a duct we are going to use and it is a metal duct, GI duct. It has ability to gain some heat, so need to consider that part of the heat load also. That's why we are considering the 10% of the total heat load. And duct leakage, of course there will be a leakage from the duct, the air going to be leaked, so we need to consider that loss also. That's why we are considering 5%. This is the standard procedure what we are considering, 10% or 5% when you are going to enter in the real life calculation. So by this we have just finished general and system components. Let's go to the zone components. This is the important factor. Now if you come to the zone components, we will have a space, thermostat and supply terminal. Come from the space, if you click on the zone component, the first thing you will see over here, it is the spaces. What exactly the spaces what we created in this last video, in the space properties part of the video. So as we agreed, the first half we will dedicate it to AHU1. So I will consider first half, for example, cabin 10 add, cabin 5 add till cabin 8. So these 5 spaces I added to this air system. That means this air handling unit going to be provide cooling and air supply to these 5 spaces. Means I am telling to this software that you need to calculate the load of the coil of this air handling unit related to only for these 5 spaces. If I enter whole spaces, the load will be more. If I enter less spaces, load will be less. As we agreed before that we are going to assign only half of the area for this half of the room, number of room for this air handling unit. That's why I'm just adding this. In the second part, I mean the second system which I'm going to create, I will add the remaining half. So let's agreed. Now here we have just added these 5 spaces over here. So next to go to the thermostat option. Now what temperature you want inside the room, this is where you are going to enter. For example, in the office, what the example we are considering over here in these spaces, the general standard temperature is 21 degrees centigrade, which is around 72-71 Fahrenheit. If you convert 21 degrees centigrade into Fahrenheit, let's see, because here the units into Fahrenheit, we must make sure it should be in Fahrenheit. So C2F, I want 21, this is 69.8, so let's say 71, make it 22, sorry, 22, 71.6, so 72 and unoccupied 75. That means the the temperature, the set point temperature of this thermostat between 72 and 75. If the temperature go beyond the 75, machine will be start. Once the temperature reach to 72, the machine will be off. If the temperature above the 72 till the 75, machine will be continuous, will be off. Then if the temperature above the 75, again machine will be start. So you need to make sure these two temperature over here. Now once you enter these two information, click or come over here and select the thermostat schedule. This schedule we created in the last video, if you remember, in the part 3a and part 3b. So I'm selecting this one and click OK. So once you click OK, this system going to be created. Let's conclude what we have seen over here. We have seen the spaces over here, number of spaces which we have created and which are appeared here, and we want to create one system, and we assume that it will be chill water system which will be air handling unit. So I agreed to the air handling unit 01, the type chill water system, air handling type, and CAV single zone system component. And we have seen various components in the air handling unit which is over here, and which type of part you want. We just freezed over here and we entered the zone components over here, and we have just assigned all these spaces to this air handling unit 1 and thermostat. We have just considered the set point. Then click OK. By this you have just finished the system properties. However, there is advanced options in this system, but this is the basic options, basic information you have to enter for the system. Let's create another system, another air handling unit. So this is AHU02, make it fast. System tab, again chill water, air handling unit, CAV single zone, system components, ventilation should be there, central cooling, there is no central heating, supply fan, okay, duct system 10%, 5% over here which is duct leakage. Let's go to the zone components, as we already assigned first half to the air handling unit 1. For these remaining spaces we are going to assign for air handling 2 from these spaces. Yeah, this is air handling unit 2. Come to this thermostat, change this is as last 72 and 75. Select thermostat 1, click OK. By this we have created two schedules, okay, sorry, two systems, AHU1, AHU2, AHU02. Now, so this is this is creating the system properties. Let's see the next part, how to generate the reports. If you want to see the reports, the final result of this calculation, once you create the system, just click on any one of the system, right click, there will be an option, select this option, the fifth option, print view design result, click on it, wait, it is going to be generate the information. It will take some seconds or some minutes before it's going to enter. Now we will have this option over here. The reports, the type of reports is going to be generated. It is there is a different types, for example, system sizing summary, zone sizing summary, ventilation sizing summary, system load size summary. What exactly reports you want, you have to click. For example, I want first 4. I want this. I don't want, if I want, I can create psychometric also. Click preview, it will generate the reports. These are the reports. Now if you see over here, the air handling unit 1, the total tonnage is 5.3 TR and total sensible coil is 53.5. The MBH, this MBH is mega BTU per hour, and the coil, this is the coil capacity, and the fan capacity over here. If you see the supply fan sizing data is 2378 CFM, and the fresh air requirement is 130 CFM. That means the supply air is 2378 and outdoor is 130. That means the return air will be 2378 minus 130 CFM. If you can see outside air, which is 115, this information, it is appeared over here because we entered in the last video in the weather properties as 11584. and this is entire in dB. All this information you are going to see. What is the resulting RH? This is the 49%. If you are a HVAC experienced engineer or basic, if you have a basic knowledge, the main important comfort factors, comfort conditions we must achieve to get the proper result is the temperature must be within the range of 21 to 24, which we already entered when we have entered in the thermostat settings, and the relative humidity must be 50%, which is it's shown here 49%, which is max is equal to almost only there is a 1% difference. So that means we have achieved the required comfort condition. To know the more details about what exactly this comfort condition, please go through my video which is named as HVAC Intro and Basic. In that you can find all comfort conditions and complete details. But here the main important point is this is the report, which is air size system sizing summary. You will have many reports. For example, this is zone sizing summary. In the each and every room, these 5 rooms we have added in individual, you will find what is the load in the individual area and individual CFM. See, the CFM is the same because I did not change any area, any lighting fixtures. That's why it's showing the same load and the same airflow requirement. So there will be another reports. So this is going to be a long it is going to be take long time if you know how to read each and every report and what is the use of each and every report. So by this part it is completed. The HAP itself is completed and use of the HAP itself is completed. Now if you want to generate the HA2 reports, you can also generate HA2 reports. See here 58% relative humidity and 6.1 tons. So something went wrong over here. So why it is came 58%, why it is not came the acceptable 50% range. So you must know what is the changes we have to make. The main change we have to make the change of design supply temperature, which will directly related to this relative humidity. But let's see, this is the cooling coil capacity 6.1 and the CFM is 3668 CFM. So by having these reports, if you submit this report to the specialist supplier of air handling unit of any manufacturer, let's say Train or York, anyone, they will select your proper air handling unit depending upon the models they have, and which is going to match your calculation. But you have to make sure your calculation must be accurate and well enough to serve the area to provide the cooling load. So by this part is finished. Please do share, like, comment, subscribe for more advanced videos. Make a request, because these up till now this is the basic videos which cover all the topics what I promised, and it is uploaded over here. For the specialized request, if you have any doubts, you can put me a message, and till that time stay tuned. Have a good time.